Namaste, I hope you are fine. So today we are going to solve the problem of the day for 3rd January. Right, so the problem is longest increasing or strictly decreasing subarray. I actually have solved this problem, so I'm going to explain it to you. So let's take the example 1. So the problem is we have to find the longest subarray, and subarray should be strictly increasing or strictly decreasing, right? So strictly increasing means the I minus 1th element should always be smaller than ith element. It should not be equal, right? Or smaller. So it means for increasing I minus num I minus 1 should always be smaller than num I, right? So it should be an upper trend. And for decreasing num I minus 1 should always be greater than num I. It cannot be equal, right? So if it is equal, then it will be increasing, not strictly increasing, right? So okay, now in this example we can consider this as to be strictly increasing, so the maximum length will currently maximum length is 2. Now take this example, this is strictly decreasing but length is 2, maximum length will be 2, and this is strictly decreasing, so maximum length will be 2. In the third example, this whole array is strictly decreasing, so maximum length will be 3. Output is 3 here and output is 2 here. In this example, all the elements are equal, that means there is no strictly increasing or strictly decreasing, so we have to return the 1, because we can consider single element as a subarray which is strictly increasing or decreasing, we can consider, right? So how to solve this? Okay, so let me explain. It can be solved in it's an easy type of problem, so we don't have we can solve it easily. So take 2 pointers right, which count increasing and decreasing subarray's length. Second maintain max length to return. So this is all we have to do. So at any point, increasing and decreasing can be 1, because if we are considering only one element, it can be considered as increasing subarray or also decreasing subarray, right? So we can initiate increasing and decreasing by 1, and we have to start from 1 to length n, and we have to compare 2 elements, so I minus 1 and I. If this is the trend increasing, if this is the trend, we will increase the increasing, else we will increase the decreasing count, right? And if both the elements are equal, we will reinitiate increasing and decreasing. And then so let's try run this code in this example. Okay, so at initial level, increasing equals to 1, decreasing 1 है, decreasing 1 है, max length 1 है, right? So I is, so at I equals to 0, I will be starting at 1, right? So the is num I is greater than num I minus 1, so yes, so we will increasing, so increasing will be 2, decreasing will be 1, and max length will be maximum of increasing, decreasing, and max. So max length will be now 2, because we will consider the maximum of all these three elements, right? Now at I is equals to 2, is this greater than this? No. Is this smaller than this? Yes. So this is this, we will go to this condition, and decreasing will be 2, increasing will be 1, and maximum will remain 2. At this point, this we will go in the third condition, these both will be 1, maximum will be 2. In this fourth point, the second condition will be considered, and this will be 2, right? And we will return max length, so which is 2. Let's try run on this, right? Or we will take 2 here. Okay, so what will happen? Initially I is 1, decreasing in 1, maximum 1, right? At I is equals to 1, this we will enter this condition and increase to 1, max length will be increased to 2, right? Because I is greater than minus 1, so this is increasing. Now at I equals to 2, this is decreasing, so this is decreasing, so decreasing will get 2. I will be reinitiated at 1, and max length will be 2, because this is maximum of all these three elements. Now at I equals to 3, these two are also decreasing, so we will increase decreasing, and increasing will remain 1, and max length will get updated to 3, right? And here, as you can see, the third condition, these are equal, so increasing and decreasing will be 1, and max length will remain 3, that equals to 4, right? So we will return 3. So answer is 3, as we can clearly see. This is the maximum length of the increasing and decreasing. So that's how we are going to, this is all in this problem. I hope you understand this problem well, and solution. We have submitted this with good time complexity. This is the best time complexity possible. So yeah guys, the time complexity and space complexity will be 1, because we are not using any variable space, we are using only constant space, right? So that's all guys. So in another video, I will gonna discuss you about this site and very first algorithm, which is KNAP problem. So we will gonna discuss you with this problem in some another video. I'm gonna start another playlist for algorithms. I found this explanation very interesting and very useful. So I hope I recommend you to read about this knapsacks. There are multiple type of knapsacks, which is zero knapsack, complete knapsack, multiple knapsacks, right? And you can try, and this is mixed knapsack, which is okay, but you can try all the knapsack problems too, but we're gonna discuss about this. So I hope this is all from me. This is all from me. Thank you for your time.